Upstream from my mooring, we're slowly running out of water and eventually come to an end, and at the end is Thorrington Tide Mill. This mill has now been restored at some considerable cost, and the lake is the stored energy. The actual mill, this mill, is about 1830, although there is evidence of a mill on this site going back to the 16th century. The actual water wheel itself is about 18 inches in diameter by about 6 feet wide, and it's wood and iron construction, and the main shaft is about 12 inches of solid wrought iron bar. A point I should have mentioned, of course, is the wheel is an undershot wheel, and here is the lake with all the stored energy. The tides come in and the gate shuts automatically, and this is potential energy to drive the mill. Although I've had great difficulty getting up here in my boat, in its heyday there would have been Thames barges to bring goods and take flour back to London. This wheel on the side is a sort of power takeoff and power input. Well, we have managed to get inside, and here I've taken some photographs, and power from the main wheel drives this larger one, and it's made up of segments of cast iron, and the wheel you see on the vertical shaft is temporarily held up from being meshed as a recent flood, so it's drying out. When it is actually engaged, it's held in position on this hexagon shaft by the wedges you see underneath. The vertical shaft you see here travels through the centre of the mill and drives all the rest of the machinery. If we move up to the next level, all the machinery is driven by such gears such as this, and they're all wooden meshed gears. The picture you see now is the sack lift, which lifts the corn up to the top of the mill and is worked on the larger wheel you see, there's a band that goes round it, and it's a form of clutch to engage the chain drive. Here at the top of the mill there's a device to stop the sacks from going through the roof of the mill. The sack comes up and hits this arrangement, which operates or slips the clutch, so reducing the drive. This is the top stone. It's the only stone which is driven, the bottom one being stationary. They don't actually touch, and the top stone is on a form of gimbal, which you can see here. And the tool you can see is for dressing the stone. All the teeth on these wheels are separate and individual, and they're made of apple wood, and sometimes they break, of course. And here you can see a selection of teeth, and the one that I'm holding in my hand, as you can see the length of it, is driven out from the bottom with a mallet and then driven back into the wheel. This would be done by the miller's boy, bearing in mind this would be done while the wheel was in motion. The flour produced would be sent through this revolving sieve, which would give 3 grades of fineness. Whilst most machinery was crude wooden devices, there was some ironwork, and these are cast iron wheels. And I found over the back of the mill some actual patterns that were sent to the foundry to be cast. Whilst here today this might seem very picturesque, at the time it would have been incredibly noisy, it would have been filthy dirty, that the atmosphere would be full of husks and dust, and it would have been extremely dangerous. There'd be no health and safety during these times. I hope you enjoyed this short video. Thank you for watching.